Thank you for inviting me. Shalom. So I work at Hearst. I'm Director of Data Science at Hearst. I work with Hearst's magazines, TV, and newspaper data, looking at images, video, audience data, clickstream data, and ad data. The team I work with and I built work with computer vision, so that's images and video as well as language, traditional ML, and the focus on recommender systems. So a little bit about Hearst. I'm in California, so you know all about it. So Cosmo, magazines, Cosmo, Esquire, Road and Track, Car and Driver, newspapers, SF Gate and the Cron, entertainment, Stakes and ESPN, A&E, Hearst Business Media owns Fitch, healthcare companies, and automotive. On the venture side, we have a group run by Ken Bronfman and opened an office recently in Tel Aviv, led by Gil Kanani, and then broadcasting. So traditional media company will have all the sort of data assets, and we pull it all into a lake. And these are typical machine learning applications at Hearst. I won't talk about any of these, though we've spent a lot of time on these things, and I'll focus on deep learning applications at Hearst. So last summer, we partnered with NYC Media Lab and worked with Professor Kyung-Hun Cho at NYU. Professor Cho is an expert on deep learning. He's a pioneer in sequence-to-sequence models. And you meet people who are really smart. He's the kind of guy who writes the book on deep learning, and we're the kind of people who read that book and apply it. So that's the sort of smartness of him. So I'm in Silicon Valley, and I don't need to tell you the applications of deep learning in various modalities, language, machine translation, have all been revolutionized by deep learning. Gesture, you've seen a paper recently on computers and algorithms able to read your lips. So if you're not focusing or you're talking in a car, the algorithm can tell what you're doing. I will focus on two applications, the application of language and vision within Hearst. So to give you a sense of the breadth of media that we have, and think of the articles that we continually publish, the images, galleries, GIFs, games even. We have a history of millions of articles within newspaper, thousands of hours of video, and the content is extremely rich. So from L, we write about brands, we write about celebrities, SF Gate, a huge diversity of content, and a diversity of imagery as well. So we're now able to understand the content, to condition on it, to look at the images and connect the images to the content. So what I will show you is a demo, two demos that connect the right image to the content, as well as looking at brand detection. So this is sort of the old-fashioned way in which we did that academics and professionals looked at image understanding. We would handcraft features, look at edges, look at patterns of edges to determine like there's a person walking towards you. All of that handcrafted features have been changed and automated, and now you've got, this is a slide from Jan LeCun, who runs Facebook AI, essentially looking at the algorithm and having the algorithm come up with these low-level features, edges, and then you see, because it's a deep neural net, it composes low-level edges to become circles and patterns, and then to compose them to higher-level features. We take all the images internally in Hearst, transform them to what we call embeddings, which represent that image. So it represents information from the low level, the mid level, and the high level, and basically we can then look at articles or images and look at what's close to them. So I'll show you a demo of our first sort of hello world. So there you see Amal with that handbag. What was that handbag? So I'll play you a demo. So it's a little UI we built called the Imaginator. Took 4 different brands, gave the algorithm examples of the different handbags for Celine. You'll see that there are different styles within each brand. So had the algorithm understand and learn, and then gave it a test. And so in the test here are images that I never saw before. Can it accurately let me know what those are? So in that example, all the green labeled things, we got it right, and then the red boxes were wrong. So this was our sort of hello world for image recognition. We did also something with, whoops. So then, so there's that image, and I can crop it, and then let me know what it is. So all of that, like right now, we've essentially automated. So that was actually a Dolce & Gabbana handbag. We take the images that we have, and as I mentioned, look at the embeddings or representations of them. And then we can also look at, so these are the sample 500 images from newspapers. And you can see that it already organizes the images without my even building a model. So here you'll have sports, you'll have politicians and criminals, and at the bottom, buildings. For magazines, our imagery is very different. You'll see the food, and you'll see that it's semantically organized in a reasonable way. So we take advantage of the semantic organization of imagery and basically built a text-to-image mapping. So text or articles, we've got lots of historical articles, and we can look at how can we translate a set of words to an image. So here's, I'll give you a little demo of what we did. We took 20,000 articles and mapped the words in those articles to the associated images. And now if I had an article and I put kittens, it would retrieve for me kittens or dogs. So I haven't trained a model to recognize dogs, but I just gave the algorithm 20,000 articles, and it can now surface the right imagery for that article. So now let's say I'm writing an article in SF Gate. I looked at this particular thing, uncrowded French coast, a vacation story in SF Gate recently. And I said, I didn't like that picture. So let's say the author or the writer was taking that content saying, suggest to me an image. So I can, instead of putting a word, I can go in there and it will surface the image appropriate to those words. So here's another example within like design. So I'm taking 5 or 6, 7 words. That was the actual article in Veranda. I can put that in, and then it will surface within the images that I have at Hearst, an appropriate image. So that's part of what we're doing at Hearst. So the goal is like translation. You have text, you're mapping text, and here's a bunch of words to images. What would be the appropriate image? So maybe it's an article about traffic, and maybe you want a police car, or like the UN, or traffic because of the UN. And then going back, here's a summer dress. Where might I use that in what article? And that might be appropriate for a summer dress, or also maybe a casual wedding. So see some references to mapping images and connecting images to words. And these are the frameworks that we use. So Torch and TensorFlow and Caffe, we've played around with all of these at Hearst. These are the GPUs I convinced our CTO to buy last summer and that we are making good use of. So on that note, next steps are making our recommendations accurate, making multiple suggestions, tailoring it to different authors and sensibilities of those authors. So one author may write something and prefer like black and white tone or monotone. Another author may like sort of jewel tone colors. So we can do that kind of personalization. And so face recognition, object localization, most of these things we've sort of ticked off. Object localization is fairly easy. And applying what I showed you to video would be sort of the next step. So on that note, thank you.